Welcome back, focused learners, to another explainer. Okay, today we're diving into a truly fascinating thought experiment. We're going to look at the cascading physical, mechanical, and ecological effects that would literally unfold if humanity just vanished. And to be clear, we aren't looking at how or why we disappear in this scenario. We're just looking at the hard data, the physics, and the biology of what happens to the world we leave behind. Through the explainer today, we're building a timeline, starting from the very first hour we're gone and stretching all the way into the absolute unfathomable depth of cosmic time.
So what happens the exact moment humanity disappears? It's a question that's captivated sci-fi writers for decades, right? But rather than relying on Hollywood tropes, we're going to use real-world engineering principles and ecological history to actually answer it. We're kicking off our timeline right at hour zero. Just picture it, a bustling world, humming with energy. Servers, pumps, reactors, suddenly totally devoid of its operators. We're going to see exactly how incredibly fast our fragile, highly tuned world unravels without us here to keep the balance.
Okay, let's dive straight into this with Section 1, the lights go out. These are the critical hours to days immediately following hour zero. Now, you might be thinking the lights would just kind of stay on until the coal or gas slowly runs out, but the reality of power distribution is way more dramatic and almost instantaneous. You see, our modern power grids require constant, active balancing. When demand suddenly drops, because, well, nobody is turning on lights or running factories, but those massive fossil fuel and nuclear plants keep generating the exact same amount of power, the frequency of the electrical current actually spikes, and the grid is extremely sensitive to these frequency changes. Within minutes, automated safety relays are going to detect this dangerous mismatch, and they'll start tripping to protect the infrastructure. Once one major generator goes offline to protect itself, that massive load violently shifts to others, causing a rapid, unstoppable cascade failure. Electrical engineers point out that it wouldn't even take days. In just a matter of hours, major corridors of the global power grid would collapse entirely.
Well, okay, there are a few brief exceptions to this blackout. A remote off-grid solar setup with some heavy-duty batteries, yeah, that might continue to cycle the lights on and off in an empty house for years. And massive hydroelectric dams like the Hoover Dam, which obviously don't require consumable fuel, they might keep spinning their turbines for a little while longer. But without us humans there to provide constant lubrication and essential maintenance, these systems will absolutely, inevitably grind to a halt. Total global darkness is an absolute certainty, and it happens incredibly fast.
Moving right along to Section 2. Nuclear plants run hot. This is what happens in the days to weeks after we disappear.
Now, what's really interesting here is that it addresses the absolute biggest fear people have in this scenario, the fate of the world's hundreds of nuclear reactors. But surprisingly, the engineering facts completely bust a massive sci-fi myth here. The myth suggests that without humans, nuclear reactors just immediately explode in these giant mushroom clouds, wiping out all remaining life on Earth. But the engineering fact is actually quite different. Reactors are built with passive safety features. The very moment they lose their connection to the main electrical grid, they automatically trigger control rods to drop right into the core, shutting down the main fission reaction. But, that isn't the end of the story.
Because even when that main reaction stops, the decaying nuclear isotopes still produce a massive amount of what's called decay heat. We're talking about 7% of the reactor's normal thermal power. To prevent disaster, this fuel absolutely must be actively cooled with flowing water for years. So let's walk through this exact sequence. Step 1, the grid fails and the reactor shuts down. Step 2, massive backup diesel generators automatically kick on to run the water pumps. But here's the catch. Those generators only have enough fuel on site for about a week. Which brings us to Step 3. The diesel runs out, the generators die, and the water pumps fail. Without flowing water, it only takes about 2 days for the remaining coolant to boil away, completely exposing the radioactive core. And Step 4 is inevitable. Without human intervention to add water, the core overheats and melts down. Now, I know a meltdown sounds absolutely catastrophic, but modern engineering has actually prepared for this exact thing. Following the Fukushima disaster, a lot of plants installed blowout panels. So instead of pressure building up until the whole building explodes, these panels allow the highly pressurized hydrogen gas to just vent harmlessly. Plus, those massive concrete containment buildings surrounding the reactors, they're designed to remain intact, keeping the worst of the melted fuel completely contained. So yes, there absolutely will be localized radiation zones around these plants. But as biologists note, the total absence of humans driving cars, clearing land, and polluting actually triggers an explosion of wildlife that vastly offsets these relatively small, localized dead zones.
All right, let's look at Section 3, Nature Reclaims the Concrete. This covers the years 2 centuries ahead. So the crucial point is, as we transition into the years and centuries ahead, our narrative shifts from the extreme fragility of human technology to the relentless, unstoppable power of ecological succession. The crucial mechanism behind this giant green takeover is called passive rewilding. Back in 1998, science fiction author Bruce Sterling actually coined the term involuntary parks for these areas. This is exactly what happens when environments are entirely unmanaged. Basically, nature abhors an ecological vacuum. Without us there to mow the lawns, spray the herbicides, or clear the roads, natural processes just spontaneously restore themselves. Seeds take root right in the cracks of the pavement, erratic disturbances like floods and wildfires go completely unchecked, and wildlife rushes right back in to revive the biodiversity. And we actually don't even have to guess what this looks like because we have real-world examples right now. Just look at the Chernobyl exclusion zone. Despite all the radiation, it's currently teeming with wolves, brown bears, and lynxes, simply because humans aren't there to hunt them or pave over their habitats. Or the heavily mined Korean demilitarized zone, it's become an accidental sanctuary for rare wildlife. The Fukushima exclusion zone has been completely reclaimed by Japanese macaques and red foxes. And my personal favorite, the abandoned SS Airfield shipwreck in Sydney, Australia, has spontaneously transformed itself into a floating, thriving mangrove forest. It's really incredible.
And this brilliantly illustrates a really profound shift in perspective. As humans, when we look at photos of crumbling buildings, moss-covered floors, and collapsed roofs, we tend to see tragic urban decay. We see the loss of civilization. But from an ecological perspective, this is a massive triumph. A cracked roof allows rain and sunlight to enter, basically turning a high-rise office building into a vertical greenhouse. A flooded subway tunnel becomes this incredibly intricate aquatic ecosystem. What we see as destruction is really just nature regaining its trophic complexity, literally rebuilding a rich, multi-layered food web right on top of our concrete.
Let's move on and see how this builds in Section 4, the far future. We are talking billions of years from now.
Okay, now we really have to zoom way, way out. We're leaving the surface of the Earth to look at the mind-bending scale of deep time. What happens to our planet and the universe it sits in long after the very last skyscraper has crumbled to dust? 5 billion years. I want you to just take a second to truly feel the scale of that massive number. 5 billion years from now is the rough timeline for when the very engine of our solar system fundamentally changes. You see, in about 5 billion years, our sun is going to exhaust its supply of hydrogen fuel. And when that happens, the delicate balance between gravity pulling inward and fusion pushing outward entirely breaks down. The sun will dramatically expand into a red giant. And this expansion will be so massive that it's expected to completely overwhelm and swallow the inner planets, Mercury, Venus, and almost certainly our Earth. After shedding its outer layers, the sun will eventually shrink down into a tiny, super dense, glowing ember known as a white dwarf, with only the surviving outer gas giants like Jupiter and Saturn left orbiting it in the dark.
But time doesn't stop there, does it? As we track the ultimate cosmic fate of the universe, it's entirely defined by the second law of thermodynamics. Entropy always increases. Over trillions of years, literally every star in the universe will exhaust its fuel and go dark. But even then, physics tells us there is an end to the remaining matter. In the infinite future, long, long after the stars are dead, radioactive decay will eventually cause even the most stable materials, the very subatomic particles that make up the universe, to just disintegrate.
But hey, we're not going to end on a completely dark note here. Current data actually suggests our universe has a flat geometry, meaning it'll just keep expanding infinitely rather than collapsing back in on itself. And, as the source material for this explainer notes, an infinite amount of time allows for the massively improbable to eventually become an absolute certainty. So think about this. Could the decay of absolutely everything be the exact blank slate required for spontaneous inflation to trigger a brand new Big Bang? If given infinite time, is the end of our universe simply the required spark for the next one? It is a massive, mind-bending question to ponder. Thank you so much for joining me on this incredible timeline today. Keep asking questions, and I'll see you in the next explainer.